What's going on, you guys? Mr. Garcia here. Got another video. This one discussing section 3, the last part from module 1, using some quantitative expressions and modeling. Fancy words for saying turning math that is in words into actual equations. Looking at numbers 1, 3, and 6 in this video. So if you have questions about 2, 4, and 5, please reach out. I made a little chart here to kind of just get you familiar with a bunch of different words that are helpful for all this section. Some of these are pretty straightforward. We just saw this for multiplication in section 2 of typically means multiplication. Be mindful about the word double and triple. That's helpful for later on as well. Less than, decrease by, these are always the weirdest. That's why I want to talk about one of those here in a second. We just saw division as well, per, right? Percent was that fraction per 100. And then equalities as well. That's helpful for our unit 2 or module 2. So let's look at number 1. Which expression best represents 5 less than y? So off the bat, people always want to say the answer is C, but it's not. When you have subtraction, it's not always straightforward as 5 operation and number. Now, definitely if it was addition or even multiplication, that would make sense. 5 more than y, 5 plus y. I like to think of it like this. It is going to be B. We have some number y. Pretend like it's, 12. And I asked you, hey, give me a number that is 5 less than 12. You wouldn't say, oh, well, then 5 minus 12 is going to be negative 7. No. You would say, oh, well, a number 5 less than 12, just do 12 minus 5. And you get 7. Yay. Same idea. We have some number y, and you want to find 5 less than that. Typically, with subtractions, especially with this stuff, you really want to start here and kind of go backwards from there. A good rule. Make numbers that are super simple and use that in this expression. Like number 3, which expression represents the sum of a number n and 6 being divided by 3. Okay, so a sum of a number n and 6 being divided by 3. I don't know. Okay, the sum of a number 9 and 6, so that's 15 divided by 3. Oh, so I would have to kind of do this one, B, because they added them together first and then divided by 3, like I just did. Notice on A, the dividing by 3 is only with the 6. You kind of need those parentheses to say, hey, this part's being added together, and then we divide by 3. Same idea for number 2 and number 4. So those are good questions to look at. And then it's a shorter video, totally fine. Linear modeling. So we'll do a couple different modelings here with this section, or with the next few upcoming sections. With linear, it is the classic format of y equals mx plus b. We don't really say this too much, mainly because they use it in context. When we say slope, that is just something that's reoccurring often. So I say the word reoccurring rate. That's the stuff that's per hour, each item, so on and so forth. Your b was your y-intercept. That is like a starting amount. That's what it means to have a y-intercept. It's where you start at. It's the flat fee. It's the one-time cost. And so on number 6, it's 2 parts. It's that part, and then something called the average cost. We haven't really talked about averages so far in these videos because it's literally the third video. But average is just taking the whole thing and dividing by how much it is. So we'll do that in a second. First part, we got a rental company charging $200 to rent a truck and $5 for every mile driven. Off the bat, I see every mile driven. My mind should be thinking, oh, those $5 is that recurring amount. It's that part that's happening multiple times. Oh, $200 in this case. Well, I'm only charging $200 to rent a truck. That fee is going to only happen once. That's it. So that $200, that's the one-time fee. That's the flat fee, whatever you want to say. My variable is M in this case. So we have $200 plus 5 times the amount of miles. If you drive 4 miles, you still have to pay $200, but then you also need to pay 20 in this case. So 200 plus 5M, the average cost just means take that whole thing and divide by the amount, which in this case would just be M, because it's the amount of miles, which would match up with, looks like B. Shorter video, but it's a good video. I might also do another one just in case. We'll do, I don't know. We'll do number 2. Actually, we'll do number 2 and 4. Why not? We get a value that's X increased by 5, and then the result is doubled. So do notice this part's happening first. Whatever happens with that part is then being multiplied by 2. That doubled is applying to everything here. So it's not just 2 times some number X. It's 2 times everything. So they did the X plus 5, and they multiplied that number by 2. Again, put an imaginary number in that place. Maybe like a value of 3. I don't know. 3 plus 5 is 8. 8 times 2 is 16. Which of these gets you 16? This would get you 16. This would get you 11. 13. Oh my gosh, what is that? 25. Wow, that's not 25. But it is 25. But it is 25. Okay, I'm down to myself. Number 4, same idea. You're tripling a value and then decreasing it by 4. So notice that tripling is only happening with the X. So it's not going to be a quantity aspect. Looks like it's only happening with the X. So it has to be 3X and then decreased by 4 or subtracted by 4. Thanks so much for watching. If you have any more questions, please let me know. But if not, have a great rest of your day. And as always, go Mavericks.